One topic is what is current source, what is voltage source, briefly presented by Saichi, computer science and engineering data science. Introduction to electrical sources. An electrical source is a two-terminal device that supplies electrical energy to a circuit by maintaining a potential difference or current flow. Sources are fundamental components in circuit analysis and design, forming the basis of power delivery in electronic systems. Two primary types of ideal sources exist: voltage sources and current sources, each with distinct characteristics and behaviors. Real world sources are modeled using combinations of ideal sources and passive elements like internal resistance or conductance. Understanding source behavior is critical for analyzing circuits forces like BEE. Ideal voltage source. An ideal voltage source maintains a constant voltage across its terminal regardless of the current drawn by the load. The voltage is independent of the load resistance. Following Ohm's law, V equal to constant, where V is the terminal voltage. It can supply infinite current in theory, but in practice, real sources have limitations due to internal resistance. The symbol of an ideal voltage source is a circle with A plus and minus polarity, making often labeled with a voltage value, example 5 volts. Examples include batteries and regulated DC power supplies using digital systems. Practical voltage source. A practical voltage source includes an internal resistance in series with an ideal voltage source. The terminal voltage is given by Vt equal to Vs minus 1 into Rs, where I is the load current. As load current increases, the voltage drop across Rs increases, causing a reduction in output voltage. The open circuit voltage equals Vs, while the short circuit current is Isc equal to Vs by Rs. Battery powered devices exhibit this behavior where voltage sags under high load due to internal resistance. Ideal current source. An ideal current source delivers a constant current I to any load independent of the voltage across its terminals. The current remains fixed regardless of the load resistance following I equals to constant, even if voltage varies. It can theoretically develop infinite voltage across open terminals, but real sources have compliance voltage limits. The symbol is a circle with an arrow inside indicating current direction, often labeled with a current value. Example 2 milliampere. Used in biasing circuits, LED drives, and active loads in amplifier design for stable delivery. Practical current source. A practical current source is modeled an ideal current source IS in parallel with an internal resistance. The output current is given by I out equal to IS into RP by RP plus RL, where RL is the load resistance. As RL increases, more current flows through RP, reducing the current delivered to the load. The short circuit current equals IS, while the open circuit voltage is equal to IS into R. Transistor based current mirrors and Howland current pumps are common implementations in analog circuits. Comparison voltage versus current source. A voltage source maintains constant voltage. A current source maintains constant current regardless of load conditions. Voltage sources have low internal resistance. Current sources have high internal resistance. In their equivalent models, voltage sources are used in powering logic circuits. Current sources are used in biasing and precision analog applications. In a voltage source, current varies with load. In a current source, voltage varies with load resistance. Then even equivalent circuits equivalent circuits use voltage sources. Equivalents use current related by source transformation. Source transformation theorem. Source transformation allows converting a voltage source with series resistance to a current source with parallel resistance and vice versa. The transformation is valid when Vs equal to Is into Rs and Rs equal to Rp, ensuring equivalent behavior across the terminals. This simplifies circuit analysis by enabling the use of then even or non-equivalent models interchangeably. The power delivered to the load remains the same before and after transformation, preserving circuit functionality. Used extensively in network analysis, especially when applying superposition or complex resistor networks. Depend control sources. Depend sources have output values controlled by voltage or current elsewhere in the circuit. Four types exist: PCVS, VCCS, and CCVS and CCCS, representing voltage control and current control sources. For example, a VCVS produces a voltage proportional to a controlling voltage V out equal to mu into Vx, where mu is the gain. Depend sources are model active devices like transistors and operational amplifiers in small signal analysis. They are essential in amplifier design, feedback systems, and linear circuit modeling. Accusation circuits. Applications of voltage sources. Voltage sources for digital logic circuits, microcontrollers, and FPGAs requiring stable supply voltage. Used in sensor interfacing to provide aggregation voltage for resistive sensors like thermosistors and strain gates. Battery management systems really and regulated voltage sources to ensure safe charging and discharging cycles. In hardware, voltage sources ensure reliable operation, ADCS, DACS, signal conditioning circuits. Applications of current sources. Current sources are used in LED driving circuits to maintain constant brightness regardless of supply voltage fluctuations. They provide stable biasing in transistor amplifiers, ensuring consistent gain and linearity in analog signal paths. In data acquisition systems, current sources exist are RTDS resistance temperature detectors for precise temperature measurement used in active loads to improve data differential amplifiers. Impact on circuit analysis. Voltage services simplify nodal analysis by fixing node voltage, reducing the number of unknown in the system. Current sources simplify mesh analysis by defining mesh currents directly, streamlining KVL equations. Superposition theorem applies differently. Voltage sources are replaced with short circuits, current sources with open circuits. The presence of ideal sources can lead to singular matrices in circuit logos if not handled with proper reference nodes. Understanding source behavior is essential for designing power efficient circuits in science hardware platforms. Current sources ensure accurate analog to digital conversion, providing precise execution.